Okay, so how many times have you seen like a headline about some big scientific discovery,
Hmm.
and then like a week later you see another one that like completely contradicts it?
Yeah,
It's
yeah.
like, are we supposed to just like know what's true even when the experts can't seem to make up their minds?
It's a fair question, and it makes you realize we don't talk enough about the scientific method itself.
Yeah.
We get caught up in the exciting results, the big discoveries, but we forget how messy and complicated the process actually is.
Yeah, it's true. We're so focused on the destination that we forget about the journey.
Exactly.
And speaking of journeys, today's deep dive is all about exploring that path,
Yeah,
how science really works,
I like it.
the good, the bad, and yeah, sometimes the strange stuff.
Yeah.
We're diving into Scientific Method in Brief by Hugh Gauch Jr. And trust me, this isn't some boring textbook definition stuff.
Hmm. Okay.
We're going to see how even the smartest people can get things wrong, how what seems totally logical can be misleading, and why this all matters more than you might think.
It's true. And this isn't just some abstract philosophy either,
Right.
because how we understand the scientific method or misunderstand it has real-world consequences for things like medicine and even the policies that shape our lives.
It's true. It reminds me of the story Gauch tells about his student who asked him, when do we get to the philosophy part of my science PhD?
How interesting.
Like they were missing something, like
Yeah.
there's this disconnect between actually doing science and thinking about how we do science.
Yeah, I could see that.
Gauch even admitted he felt that same way when he was studying soybean yield trials for his PhD.
Really? What happened?
Well, that's where it gets interesting. He realized it wasn't his equipment or even his stat skills that were holding him back.
Huh.
It was actually this core scientific principle, parsimony.
Oh, wow. I see. So he was making things more complicated than they needed to be.
Exactly.
Interesting.
He hadn't fully grasped the importance of finding the simplest explanation.
That's really profound when you think about it.
Yeah, and those fundamental principles like parsimony, they stick with you.
Hmm.
Technology changes so fast, but these core principles of science, they always apply.
Absolutely. In a world overflowing with information, being able to cut through the noise and make sense of things is crucial. And that's where a strong understanding of these principles is so important.
So it's not just about being a better scientist, it's about being a more informed citizen. Okay, so let's jump into some of those messy bits. Then Gauch talks about these four big challenges to the idea of science being this totally rational thing.
Yeah.
He calls them elusive truth, theory-laden data, incommensurable paradigms, and empty consensus.
Right.
And before anyone listening thinks like, oh no, are they going full conspiracy theory here?
Right.
He's not saying science is fake.
No, no, not at all.
It's more like he's making us look at the parts of science that are messy and human.
No, exactly. He's saying if we're going to put science up on a pedestal, we got to be honest about what it can and can't actually do.
So no more perfect science facade then.
Well, every field has its imperfections.
True. True. Okay, so tell me more about these deadly woes, as Gauch calls them. What's the first one about?
Well, the first one, elusive truth. That one gets at the heart of what science can really prove. Like, can we ever say with 100% certainty that a scientific theory is completely true? And it turns out
I'm guessing no.
you'd be right. We can never be 100% certain. It's more about getting closer and closer to the truth, but accepting that we might never fully grasp it.
Huh. So everything we learned in school could be wrong then?
In theory, it could be revised or refined as we gather more evidence, but that's what makes science so exciting. It's always evolving, always pushing the boundaries of what we know.
Okay, so it's more about the journey than the actual destination.
Exactly. And that leads us nicely to the next challenge, theory-laden data, which basically means we can't observe the world in a completely objective way. Our past experiences, our beliefs, even our culture, they all influence how we interpret what we observe.
So it's like we're all wearing these rose-colored glasses that we don't even know about.
Yeah, that's a great way to put it. And it's why good science requires us to be super self-aware, constantly questioning our assumptions and acknowledging that we might be missing something.
It's like that saying, if you have a hammer, everything looks like a nail. We tend to see what we're looking for, and we fit new information into our existing understanding.
Exactly. That's why diversity in science is so important. Different perspectives can help challenge our assumptions and reveal blind spots we might not even know we have.
Makes sense.
Oh.
So what about this incommensurable paradigms thing? It sounds pretty intense.
It's really about how we frame scientific questions. Sometimes you have two theories that are so fundamentally different, so based on totally different worldviews, that it's almost impossible to compare them directly.
Huh. So it's like you're speaking two different languages almost.
Exactly. It's like trying to have a conversation about color with someone who's been blind since birth. Their experience of the world is so fundamentally different that even basic terms might not translate.
Wow, that's a powerful image. So if we're never really 100% certain about anything and our observations are biased and sometimes we can't even agree on what questions to ask, it's kind of making me question everything.
Well, remember, Gauch isn't presenting these challenges to discourage us, but to encourage a more nuanced view of science. It's about acknowledging the limitations, not giving up altogether.
So where do we go from here? It feels like we've tumbled down the rabbit hole.
Well, Gauch then introduces this surprising ally that can help us navigate these murky waters, and that's common sense.
Common sense, really. I thought that was the opposite of science.
It might seem counterintuitive, but common sense provides this foundational layer of assumptions that even the most complex scientific theories are built upon.
So you're saying it's not about rejecting science or going with our gut feeling all the time, but recognizing that even the most advanced science has to start somewhere, and that somewhere is often common sense.
Exactly. It's like Gauch says, moving cars are hazardous to pedestrians. We can't prove that with 100% certainty, but we still act on that assumption every day. We don't need a double-blind study to tell us to look both ways before crossing the street.
It's like this inherent understanding of how the world works that we all share.
Exactly. And it allows us to function in the world without questioning everything all the time. But of course, we also need to balance common sense with a healthy dose of skepticism because our intuition isn't always right.
Right, like that experiment where people have to predict the path of a ball dropped from a moving object.
Yes. Everyone, even people who understand the physics, intuitively thinks the ball will drop straight down. But it doesn't. It follows a curved path because it keeps moving horizontally at the same speed as the object that it was dropped from.
It's crazy how our intuition can be so strong, even when it's wrong. Which is why we need science, right? To provide that reality check.
Absolutely. Science helps us see beyond the limitations of our own perception. And here's where it gets really cool. Gauch argues that this principle of parsimony that we talked about earlier is deeply connected to this idea of common sense.
Okay, so it's not just about keeping things simple for the sake of it. There's something deeper going on here.
Exactly. Seeking the simplest explanation often leads to more accurate results. Gauch talks about how this plays out in things like designing experiments. He gives an example of a technique called incomplete blocks, which is a really clever way to increase the accuracy of your findings using a parsimonious approach.
So it's about working smarter, not harder.
Exactly. And this idea of parsimony isn't just limited to science either. It's relevant in so many areas of life, from designing efficient systems to developing new technologies to even things like criminal justice reform.
Whoa, criminal justice reform. How does that work?
Well, Gauch gives this fascinating example of a study on crime rates. The researchers were trying to figure out the biggest factors that contribute to crime, and initially they included a huge list of variables, but then they used a parsimonious approach to narrow it down to the most important ones.
So instead of getting bogged down in all the tiny details, they focused on the big picture.
Exactly. And what they found was that a simpler model one that focused on a smaller number of key variables actually provided a more accurate and insightful explanation of the data.
So sometimes less really is more.
Exactly. And that's where Gauch's concept of Occam's Hill comes in. Imagine a hill where the top represents the most parsimonious model, the perfect balance between simplicity and accuracy.
Okay, I can picture it.
If your model is too simple, you're on one side of the hill missing important information. If it's too complex, you're on the other side fitting the noise in the data rather than the real signal. The goal is to find that sweet spot at the top of the hill where your model is as simple as possible but no simpler.
Occam's Hill. I love that. Such a clear image. So parsimony matters in everything, from soybean research to understanding crime rates. It's a pretty powerful principle.
Yeah.
And it brings us back to that original question. How do we make sense of all the information out there, especially when it comes to science?
Right. We're bombarded with studies and claims and so-called facts. It can feel overwhelming.
So we can actually get a handle on this stuff,
Yeah.
even if we don't have like a science degree.
Exactly. It's not about blindly trusting experts or thinking that complicated words equal truth. It's about asking questions, being willing to dig a little deeper, and having a healthy amount of skepticism.
Okay, I like that skepticism, but like with a purpose.
Mm-hmm.
So how do we actually do that? What are some things we can keep in mind?
Well, first off, don't let jargon or really complex explanations intimidate you. Sometimes the simplest explanation really is the best one. Remember Occam's Hill? Right.
A more complicated explanation isn't necessarily better.
Yeah, sometimes it's just a way to cover up the fact that there's not much substance there.
Exactly. The next thing is to pay really close attention to the assumptions being made. Gauch calls them presuppositions.
That sounds kind of fancy.
Yeah, a little bit, but
Uh,
it's an important point. Basically, what are the underlying beliefs that are shaping the research? Like the questions they're asking, how the study is designed, even how they interpret the data. Are those assumptions clearly stated, and do they even make sense?
so it's like looking at the whole picture, not just the data itself.
Exactly.
Yeah.
And another thing, be wary of anyone who's claiming to have all the answers. True science is a process of discovery, and good scientists are always open to changing their minds when new evidence comes up.
Humility even in science. Exactly. And don't just read the abstract or skip to the conclusion. Pay attention to how they actually did the study. What was the sample size? Did they have control groups? Were their methods even appropriate for the question they were asking? These are all things to look for.
Be a science detective.
Yes. And lastly, don't just passively take in information. Actually think about it critically. Does the conclusion make sense based on the evidence they presented? Are there other explanations that they didn't consider?
Don't be afraid to ask those questions.
Exactly. If you can do those things, if you can be a little skeptical, pay attention to the assumptions being made and really look at the evidence, you'll be well on your way to being more informed and making better decisions about scientific information.
This has been amazing.
Yeah.
You know, who knew that something as simple as dropping a ball could teach us so much about science, about how our brains work, and how easily we can be tricked by our own intuition?
Yeah, it's a good reminder that things are often a lot more complicated than they seem. And our intuition, while helpful, isn't always right. That's why we need science to help us see past our own biases.
And as something as straightforward as physics can be tricky, imagine how much more complex it gets with things like nutrition or economics, where there are tons of factors at play, different opinions, and sometimes even more at stake.
Absolutely.
It's a bit intimidating, but it's also empowering to realize that we have the tools to figure this stuff out.
Well, this has been a great starting point. We've only scratched the surface here, but hopefully it sparked some curiosity and encouraged you to keep asking those questions.
Yes, because at the end of the day, understanding the scientific method isn't about memorizing a bunch of rules. It's about being a critical thinker, always questioning things,
Yeah.
and having that passion for uncovering the truth, no matter how messy it might be.
Well said.
And that's a journey we can all be part of. So next time you see some headline that makes you wonder, really? Is that true? Don't just keep scrolling. Take a closer look.
That's
Ask
right.
some questions. And remember, even a little bit of knowledge about the scientific method can go a long way. It's a superpower we all have within us.
I like that.
That's it for today's deep dive. We'll see you next time.